Okay, so a quick update. In my last video, I was wrong on a couple of things. Firstly, kind of superficially, the near calculation, I realize it's just easier to detect whether or not the point is above or below the surface, so I've just changed that in this little applet. The link's still there in the old description. I've also updated a new link in this one. Um, where was I? So the near calculation has changed. Now I'm just finding the height of the point minus the height of the surface, which gives a much better, um, it's just better in terms of simulating this. The main thing, I started in the last video when I was explaining the normal vectors, and that's because I was way off. I don't know what I was thinking. But clarity hit me as I was on a walk. Obviously, if I go forwards in x by a small value, say 1 over n, then I'm going to go up in height by a small value, 1 on n times the partial derivative. By definition, that's what the partial derivative tells you. Pretty much, if that is h, then the partial derivative will increase by h times whatever your change in x is. And in practice, that's how you could use the partial derivative to find the change in z over the change in x. It turns out when you do a cross product, these 1 over n terms end up being the same across all 3 points. So every single point here is going to have a 1 on n squared term, which means when I take the unit vector, it doesn't actually matter what I make n. So let's show you what that looks like. N does not affect what that unit vector is at all. So really it doesn't even need to be there. What else? That's pretty much all I had to say. That makes that makes this work now properly. The only other thing, I realize I probably could have done this using polar coordinates, and maybe there's a nicer way to simulate it with polar coordinates, but I wanted this to be generalizable. So what I mean by that is I wanted it to work for any sort of surface. So I have a bunch of these, but here's a different surface. So this is a surface of sine x times sine y. It looks something like this. And all I really need to do to update this program is I just need to change what the partial derivatives are. When I change those partial derivatives, according to whatever the updated function is, then the program will work as intended, and the balls will bounce off the surface and scatter according to whatever surface you put in there, which I think is really neat. It's really good that it's generalizable so easily. This one's just a little bit cleaner. I've included less components just because I want it to run a little bit faster. So I've simplified the expression for calculating n, and I also simplified the expression for calculating VF, but otherwise this works exactly the same as the one shown in my previous video. So yeah, please feel free to play around with this, come up with some cool designs, some cool functions, and let me know what you find.